Chapter 2, Paragraph 5, Distillation and Adsorption. Okay, so those are both separation methods. And with separation methods, you basically separate mixtures. And just a reminder, a mixture was a substance with more kinds of molecules. So I don't have like one kind of molecules. I have more kinds of molecules. Okay, we already saw some. We saw extraction. This is a C. We saw filtration. And we saw evaporation. Kind of mixture they separate. Extraction is basically solid. Like for example sand and salt that you can separate with extraction. Then the filtration is solid liquid. And that is like, for example, sand and water. Sand is the solid, water is the liquid. And then evaporation is a solution of solid liquid. Like, for example, salt in water, where you can actually evaporate the water and keep the salt. It's based on different in extraction is based on difference on solubility. This is on size of particles. And this is on this is based on evaporation speed. They also call it volatility, but you probably never heard of that word, so that's why. This is just how easy does it actually evaporate. This is obviously how big is it, and this is the solubility is does it dissolve or not. Like the sand doesn't dissolve in water, and the salt does. So that's why you can separate sand and salt with extraction. Okay, there are two more for today, and those are distillation and adsorption. I'm just gonna fill up this table and then I'm gonna explain what it actually is. This is a solution of two liquids, and this is a solution of smell, color, or taste. This one is based on boiling point. And this one is based on how easy does it attach. So this is does attach or not. Okay, first I'm gonna work on distillation, and then we're gonna do the absorption thingy. Distillation. Then you have two liquids with different boiling points. And those are heated. So we're going to heat this mixture of two liquids. First I'm going to heat it. When heating, the liquid with the lowest boiling point evaporate, which makes it gas. Then we're going to cool down the gas. Cool down the gas. And then obviously it turns into liquid again. Then you will think why, because then I just turn it back, but meanwhile I'm just going to lead the gas somewhere that it doesn't end up in the former liquid. Okay, and then you're just going to tap the liquid. This is a cube. Okay, well, it looks a bit like this. And you know my drawing skills suck, but I'm just going to try. So there's this bowl. It's called a flask, actually, with the liquids. Then I just use either a Bunsen, mostly a Bunsen burner, just to heat it. This is a burner, obviously. And then I'm going to, there's a thermometer here. And then I'm going to lead it here into a tube. And this tube ends up in an Erlenmeyer flask, or anything else, but I'll just use the Erlenmeyer. It just drops in here. This tube is basically double. There's another tube around it, and then I'm going to add water. And this water is to cool. And the water has to go out too. So in this tube we cool the water down. So for example, if I have like water and alcohol, water has a boiling point of 100 degrees, alcohol of 87. So this one will evaporate earlier. So I'll have the vapor here, the gas, and the gas will flow in here, and there it will cool it down, so it ends up in liquid again, somehow along the road, and then it drops into my Erlenmeyer flask. So I end up with alcohol here. The water, it doesn't evaporate, or at least not that easy, so the water will be left over here. And this is how distillation works. Then about adsorption. In adsorption, I'm going to separate, mostly actually remove, smell, or color, or taste from a liquid using active coal. So I just add active coal. Mostly we use Norit for it. You might have heard of it because you use it when you have diarrhea. And then I'm just gonna filter it out. And it basically works like this. I have the coal, and then I have my substance that I want to remove, like orange balls, and those orange balls attach to the coal like this, and then the coal is surrounded by all those orange balls, which can be either taste, color, or smell. Then obviously this whole thing gets bigger, and then you can filter it. Because filtration was on size of the particle, so when the size gets bigger, it will stay in the filter.